This last question, this is from 2014 exam. To restore the vintage train, the members of a train club need to complete 13 activities. Network shown below. Determine the earliest start time for activity F. Alright, so this one, if you already know how to do this, just skip this. However, I'm just going to go through this for the sake of the question. So, the earliest start time 0. In this case, this can start at 5. This one here, B, earliest start time for E is 7, because if we go up and down, okay, 5, this becomes 11, and this becomes 14, but I'm just going to keep that in the back of my head that it could be less, so 5 plus 2 is 7 plus 4 is 11, good, so that means it is 14, and 14 plus 7 is 21, but I'm going to pencil that in, so I don't know just yet if that is 21. Alright, so let's keep going. 7 plus 4 is 11, and 11 plus 2 is 13, but I'm going to check that with the other nodes. 5 plus 2 is 7, plus 3, 10. Okay, so that's good. And 13 plus 6 is 19. And the last one is this one here. 7 plus 2 is 9. And so in this case, the earliest, the minimum time required is 21. Good. So let's go through the backward scanning at this time. So 21 take away 6 in this case is 15. There's no really other way to do this. So 21 minus 7 is 14. 14 minus 3, 11. 11 minus 6, 5. And 5 minus 5 is 0. And the other parts, so 21 minus 6 is 15 minus 3 is 12. 12 minus 2 is 11, but we'll keep that there for now. So 15 minus 2 is 13. 13 goes here. 13 minus 4 is 9. And we've got our latest start times as well. So the earliest start time for F is, where is it? Here. So that's 7. The minimum time in which all 13 activities can be completed is 21 hours. So they've actually told you the path, critical path sum. What is the latest start time of activity L? Now, activity L is here. Okay, activity L can start at the latest at 12 hours. And what's the float time of activity J? Well, J is up here, so float time is equal to 13 minus 11, which is equal to 2. Alright, let's look at the crashing questions now. Just before they started restoring the train, the member of the clubs decided they need to add activity X to the project. Activity X will take 7 hours to complete. Now, activity X has no predecessors, but must be completed before activity G starts. What is the latest starting time of activity X, if not to increase the project? So, there is some sort of project here. Okay, there's activity X, and it takes at least 7 hours. So in this case, I would say this one needs to be 14 minus 11 minus 7. In this case is 4. Okay, so it needs at least a time of 4 before activity G, activity G and X can finish at the same time. So if this takes 7, 14 minus 7, so we got 7 there. All right, now in this case it is 11 minus 7, which is equal to 4, which is what we just discussed. Now this question here, E, is a bit of a tricky one, and we need to go through each element. And there's a quick way to do it, but let's go through this thoroughly. Alright, so let's investigate what the critical path is in this case. So the critical path is A, C, G, K. Alright. And I'm not going to scroll down for this one because we're going to have to do a lot of working for this. So activity A can be crashed by a maximum of 4 hours. Determine the least cost of crashing activity A to give the greatest reduction in the minimum completion time of the project. Alright, so critical path analysis. Let's write down the paths, which is A, C, G, K. And that will take 21 hours. Alright, we need to have a look at the other paths and have a look at how they impact the finish time. So let's have a look at A, D, E, H, K. Okay, and in fact, I'm just going to write them all out now. Alright, so these are all the possible ways for the project to be finished, and if we look at the times that it requires, I'll leave this for you to add up yourself, but I'll just give you the numbers now so we can get the concept. So 17, 10, 16, and 18. So in this project, we can only crash A, but we can crash it as much as we want, but only A. Actually, can we crash it as much? Up to 4 hours only. So we have to be wary of this side right here because none of that's going to change. Only A is going to change. So let's reduce A by 1 hour. So if we reduce A by 1 hour, this now becomes, so minus 1 now becomes 20, 13, 13, 18, and 17. That's okay, because this is still the critical path. It still takes 20. So let's knock off one more. So this now becomes 19, 18, 12, 17, and 16. This still is the critical path. So let's knock off one more. And so this becomes 18, 17, 11, 16, and 15. And you can see with the last one, if we go one more, this right here now currently matches up with this. If we reduce A one more time, what will happen is that the critical path will change, and BEHK, it will still take 18 hours. So the least cost will mean that we're taking 3 hours off A, and that'll be at a cost of, what is it? $90 times 3, which is $270. Okay. And lastly, let's look at this question, 2016. The directed graph below shows a sequence, and you can see with this, it's a multiple choice question that's asking you 3 critical paths would exist if the duration of the activity is something. Well, this doesn't really involve crashing, but it involves the same sort of skill. So let's go through the path analysis now. We get 0, this will be 5, this will be going through the BE, that'd be 8. I'm going to keep 12 there just in case, and then we get 20, so that could change. So 0, 2, 2 and 8 goes here, 2 plus 8, yep, and 3 is 11, so that means 12 is okay. 2 plus 1 is 3, but there's another path. 3 plus 4 is 7, comma, 7 plus 2 is 9, so in this case this stays as 12, and B to E takes 3, 3 to that. Good. Are all the vertices labelled? Yes. So now let's use backwards scanning. So 20 minus 8 is equal to 12, 12, 3 is 9. 9 minus 6 is 3, but I'm going to double check. 12 minus 2 is 10. 10 minus 1 is, yep, that's good. So 12 minus 4 in this case is 12. Sorry, 8. 8 minus 2 is 6. And then 8 minus 5 is 3. And now a critical path now becomes this, 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 and this. So let's write down the actual path, which is B, E, I, L, which takes 20. Now, we need to pretty much write down all the other critical paths. Oh, not critical paths, but paths for this. So ADIL is equal to 19. BFJL is equal to 17. CGJL is equal to 13. And CHKL is equal to 19. So you can see with this one here, even though it doesn't talk about crashing, it still involves the skill of pretty much looking at which paths can be manipulated so that it can maximize the efficiency. So let's look at each option. I is going to be reduced by 2 hours. If I is reduced by 2 hours, okay, that is not a possible option because now actually we'll come back to that one. So if F was going to be increased, so sorry, let's look at C first. C is going to be irrelevant. So if G is increased by 6 hours, where is it? Where's G? So this now becomes a 7. Since this is not on the critical path, 20 is still going to be the largest value. So in other words, C is not a possible option. If we look at K, K is going to be increased by 2 hours. You get 8 plus 5, which is equal to 13. 13 plus 8, 21. It doesn't, it pretty much becomes the new critical path. So you don't want K. F is going to be increased by 2 hours. So F is going to be increased by 2 hours, and now this becomes 6. If this becomes 6, this becomes 9. 9 plus 2 is 11. 11 plus 8 is equal to 19. So this is a common answer that this would now become 19. But the only problem with that is that the critical path hasn't changed. It's still 20. So in this case, F is not a possible answer. And let's look at I. I was going to be reduced by 2 hours. Now, if you reduce I by 2 hours, that now becomes 10. 10 plus 8 is 18. We've only gotten 2 new critical paths after this, which is 19 and 19, but we want 3 critical paths. So E needs to be reduced by 1 hour. In this case, if this becomes 4, that becomes 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 8 is equal to 19. So you get 19, 19, and 19. You get 3 critical paths for this question.